All right, so the homework, it was doing things a little different. Is there one or two that stick out that you'd like to go over that you weren't sure about? All of it. That's not an option. Go, Casey.
Number 11, please.
Yeah, that's a great one. Thank you. Number 11. Number 11, we have a negative, and then we have two sets of parentheses of x plus 3 and x plus 3. A little too much talking, guys and girls. We have a quiz tomorrow. We're going to review for that after I'm doing this. Number 11, they tell us that h at x is the same thing as saying y equals negative x plus 3, x plus 3. Okay, so it looks a little different, but is there something about this problem that you can know about the parabola's direction? Yeah. Goes down. That negative out front means it's going to go down. Okay? But I have x plus 3. I happen to have it twice. Okay, so if I did this, I'd set it equal to 0, subtract 3, and get x is equal to negative 3. If I solve the other one, I'm also going to get the same thing. So all this really means is the vertex of this parabola is going to rest on the x-axis. Does that make sense? Because I had x plus 3 twice, there's only can be one answer. And this answer is going to give us negative 3, so we take x plus 3, one of them, set it equal to 0. So this parabola opens down. If I had multiplied out x plus 3 and x plus 3, what would my a value be? Negative 1, good. So this is a good one to have as far as the growth with the 1, 3, 5. But rather than 1, 3, 5, because if I were to multiply this whole thing out, this would have came out to negative x squared eventually. So I'm going to have this, this, and this. Okay? So that means I'm going to graph downward. So I'm going to go right one, down one, left one, down one. And then from the red points, I'm going to go right one, down 3, and left one, down 3. And then I go right one, down 5 from there. But my graph's not going to hold it, right? So that becomes my parabola. That's what it's going to look like. So the 1, 3, 5 pattern would work. You could have plugged in like negative 2 and negative 4 would have given you the same. If you did it as a t-table, you could have plugged in negative 1 and negative 5 to the table, and it would have came out the same as well. Is that all right, Case? Yeah. What else do we see on that? 11 others to pick from. 6? And then 9, and then we'll call it good.
That's good.
12. 18.
And then 1, 2, 3, 4, 5.
Where did my pencil go?
6 what was? So they're using t at x, and again, t at x is the same thing as saying y equals. Okay? So the negative out front would indicate what? Goes down. Okay, so I'm going to take my 2 parentheses, set them both equal to 0. Okay? R-I-T. Somebody bogart your pencil? Not this week. Can I continue, or should we just wait? All right. So I find that it crosses x here at positive 1. I find it crosses x here at negative 4. Now I have to find what's in between those two. So I could count inward. I could say, okay, I come in 1, come in 1. Oh, kind of happens in the middle. What's in the middle between negative 1 and negative 2?
0 or negative
Negative 1.5. Okay? So, negative 1.5 is the x component of my vertex. Let me stop there for a second. How did I figure that out? Is that red dot that's on there, is that my vertex? No, it's exactly in the middle of 1 and negative 4. So if I count in each way, count into 0, count into negative 3, cool, count into negative 1, count into negative 2, and then I have to come together, so right in between. So what do you think I should do with that x value of negative 1.5 to figure out the y value? Plug it into the original. Good. So I'm going to plug that negative 1.5 in here and also here. So I have negative 1.5 minus 1, negative 1.5 plus 4. Okay, this is going to give me negative 2.5, and that's going to give me positive 2.5. 25 times 25 is 625. 2.5 times 2.5 is 6.25. Times this negative times this positive, or negative. So this is going to come out to 6.25. So negative 1, 6.25. 1, 2, 3, 4, 5, 6.25 is about up here. Okay? Is this a tougher one to pattern graph? Sure. It's growing downward. It's growing at the negative 1, negative 3, negative 5 pattern. So you have to be careful on this when you count right and down. So I'm going to count right 1, and then down 1 comes to about here. I'm going to count left 1 and down 1. Notice I went in between, included the halves. Okay, I could keep going, but right now I have enough points to graph this graph, so let's just graph it. Okay, I have 4 identified points. Does it cross the y-intercept? Yeah, I'd say if I multiplied it out, it would come out to be positive 4 right there. That might be important, but it's just an extra point. When you're asking for questions to go over, is it a good choice to just screw around while it's being gone over and then come to me and act like you understand everything? Okay, I'm just kind of confused by this. And yes, I am identifying you. Okay? Anything else to go over? Yeah. Number 9. Huh. So they have f at x. It's the same thing as saying y equals. Just functional notation. Where would you guys think they would cross the x-axis? 0 is 1, definitely. I like it. Where's the other place? Careful. Remember I set it equal to 0. X minus 4 equals 0. So I'd have to positive 4. So 0 and positive 4. What number? Let's see. If I come in, I get to 3, get to 1. Oh, this will be nice because this is right in the middle. So how do I find the y component of this? Plug 2 in. This is parabola, open up or down? Up. Okay? So if I plug that 2 in to here and here, I'm going to be able to get some answers. So I get 2 minus 0, 2 minus 4, 2 times negative 2. That gives me negative 4. So negative 2, 1, 2, 3, negative 4. If I pattern graph that, multiply that out, it's going to come out to x squared. So can I pattern graph with the 1, 3, 5? Sure. Yes. 1, 3, and 5 is going to work. Again, how I understood that works is if I were to start multiplying that out, I'd have x squared, or x times x, which gives me x squared. Everything else is So there, so I have a pattern that's going to graph at 1, 3, and 5. So from here, I'm going to go right 1, up 1, left 1, up 1, go right 1, up 3. Oh, that fell right there. Left 1, up 3, fell right there. Cool. We have enough spots. I mean, we could keep going. We could go right 1, up 5, and left 1, up 5. We do have enough room. Do we have to have that many points identified? No. Where's across the y-axis? There at 0. What's the axis of symmetry on this one? X equals 2. Good. Yeah.
Wait, how'd you get the -4?
I plugged this 2 in to here and here and just did the math. 2 minus 0 is 2. 2 minus 4 is -2. Multiply that. Huh. Cool. Let's, I have some review sheets that we're going to work on and go through some problems. Again, we have a quiz tomorrow, and it's going to have quite a bit to, I think we will be able to handle it nicely. I'll hand this sheet out again so we have a little bit of review. Cool. All right, it's a blank sheet. I mean, it has a graph. It says review for quiz on Wednesday. Okay, cool. For these problems, we need to find the axis of symmetry. Okay, that'll be something that they'll ask on the quiz. A maximum or a minimum value, and that comes down to, thanks, sir. That comes down to the y component of the vertex. The vertex, the domain, the range, the interval where it's increasing, roots, and the y-axis crossing. Okay? These are all things we've covered, but I'm not sure if we're perfect on it. So the first problem on each page we'll do as a table. The second problem we will do as a pattern graph. Okay? Sometimes the table is going to come in a little bit better. There is on the test one problem that says, hey, use a table, and then it says one, use a pattern graph. So if you feel totally comfortable using a table, you're probably set. If you're totally comfortable doing a pattern graph, you're totally set. Because, like, we pattern graphed off on this one, right? But if we said, hey, fill out a table, oh, well, the vertex is here, 2, -4, and then I have the point 3, -3, and I have the point 1, -3, then I have the point 4, 0, and I have the point 0, 0. There's your table. It's filled out. Right? And if it said to pattern graph, for the most part, everything's going to fit on there, so we're going to be able to figure out a lot of points real quickly. Okay? So the first, can I move off the screen?
Yes.
That was just an old problem. All right, let's do, this is our first problem. Y is equal to x squared plus 4x minus 3. And we're going to do this as a table, okay? And again, I bet you the pattern graph is going to come out very similar. So, let's go through and start answering some of these questions. Find the axis of symmetry. I can't do that yet, can I? Find the max or min value. I can't do that yet. But I can probably start finding the vertex. So, where did we lead to start finding the vertex? What was our original thing? Negative b over 2a, and then we plug it in, right? Find the y. Okay, so my a value is 1, my b value is 4, my c value is -3. Negative b over 2a comes out to -2, because it'll be -4 over 2. -4 over 2, it comes out to -2. Good job. All right. If I take that -2 and I plug it back into the original equation, I'm going to plug it in here. If I plug -2 in there, what do I get? 4, right? And then -8, so 4. So that was, underline that, 4 minus 3. 4 minus 8 is -4. -4 minus 3 is -7. Okay. I think your grid's going to allow it. My grid's off. I'm only going to +6, -6. I just didn't adjust it. I'm sorry. But I think I can still do it. So So my vertex is this. Let's plot that. So -2, -7. Would you guys buy that it's on my graph about down there? On your graph, it should fit. So some answers now I can answer about this. I know the axis of symmetry. What is it? X equals -2, okay? Now, is it necessarily asking you to graph it? No, but we just are able to identify it. So we have the axis of symmetry, we have the vertex, the domain, the range, the interval where it's increasing, the roots, the y-axis crossing. I might be able to do the y-axis crossing right now. What do you think? Any ideas? Has to do with one of our letters up there. Say that one more time. It has to do with the C. It's right here. So 0, -3. That's where it crosses the y-axis. So 0, -3, right there. And I guess, you know what you do? You could find a point symmetric to that real easily. How far is the vertex from the y-axis? How far is the vertex from the y-axis? 2. So I count over 2. 1, 2. What happens if I go here? 1, 2. Where does it fall on this line? -3. Good. Why? How do I know that? I didn't even pattern graph. It's symmetric, right? So sometimes you might be able to use the y-axis crossing to identify a mirror image point, because remember the axis of symmetry goes this. Okay? We're supposed to do this as a table, but what's kind of cool is we only have 2 points left to do. So if we did this as a table, we'd have x and we'd have y. My vertex is going to be here, -2, -7, -1, -3, and then 0 and -4. But we already know those. We've already done them. They already fell up there automatically. How can I find here and here? Plug it in. So which one's easier? I don't know. It's -1. -1 squared is 1. 4 times -1 is -4 minus 3. 1 minus 4, -6. So if that's -6, that's -6. So if that's -6 and that's -6, and if we pattern graph, right one up, one left one up, one right one up 3, it's there. I don't know if we can find where it crosses the x-axis. Maybe we can. Let's see. If we were to factor this out, 3 times the 1, -3 times 1, I get -3. In order to get a -3, I need a positive and negative to be multiplied together, which are 1 and 3, right? Is there a way that I can have a positive and negative 1 and 3 that would add up to 4? What do you think? Can I take 1 and 3, 1 being positive, 1 being negative, to add up to 4? No. If that was a positive 3, then the answer is yes. But that -3, it's not going to factor. So I don't know quite where it's going to cross the x-axis. Somewhere here, somewhere here. Do I know exactly? No. It's called irrational. It's irrational because I can't factor it. It's irrational because if I truly use something called quadratic formula to do it, I'd get an answer with a square root in it, and that square root would not have worked. So, answering questions. Axis of symmetry, we have max or min value. Oh, I think we could do the max or min value. Is it a minimum value or a maximum value that I have up there? It's a minimum. So we have a minimum value. The minimum value happens to go with my vertex, but what part of my vertex does it go with? X or Y? Goes with Y. What's my Y value of my vertex? So there's my minimum value. Yo.
On the quiz, will there be something saying use table, or can we use any method?
One what might say use table, and one might say, and then there's like one that's use table, one that says use, and then the rest say use whatever. But if you feel good about pattern graphing, which I think you do, pattern graph it, and then fill the table back in. Right? I mean, because I would have no idea if I was looking at it going, yeah, you just got a table filled out. Cool. So that's how I would approach it to curve the system in your favor. Vertex domain. Oh shoot, domain. What did we say the domain's always going to be on these?
Negative infinity, positive.
There you go. Domain's negative to positive infinity. So that's got to be a gimme for you. What's the range? No, not negative 3. Huh? Negative 7? Positive infinity. Okay. Negative 7 to positive infinity. I like it. Okay. So the range is going to deal with the y component of the vertex. If it opens up, it goes to positive infinity. If it opens down, it's still the y component, and it goes to negative infinity. Okay. Where is it increasing? This is one chunk. I will tell you that it's increasing from here to here. This is all increasing where it's blue. Okay? So it's increasing there. So remember, we talked about this as a roller coaster. The roller coaster comes down a hill, it flattens out for a moment, and then it starts going up. So that means it's going to be a rounded bracket, both sides. So where is it increasing? Which x component of the vertex is going to tell you it's increasing? Negative 2. What? So the x component, so from negative 2, where am I going? Infinity. Okay? So from infinity to 2, it's decreasing. From here to here, it's increasing. So we might just ask where it's increasing. We probably won't go decreasing. Had we answered everything? Do we know the roots? No. Why not? They're irrational. So again, if it says use the table and you feel better about pattern graphing, pattern graph it, figure out those points, plug them back into your table. Yeah. Yeah, you can use the axis of symmetry. The axis of symmetry is the dividing line. It's always going to be a round bracket. It's either going to go from that point to infinity or that point to so if it was an upside down parabola, it would be increasing from negative infinity up to that point. But
If it was going down, would you write negative 2, negative infinity?
No, negative infinity to negative 2. I'll show you. We're going to do one. Next one's actually going to be upside down. So, can I clear this? We good? Try doing this one. Try doing this one as a pattern graph. See how you do. Try and answer the questions. Okay? I think you have enough knowledge of how to do it. Their vertex I already found. Hey, how did I get that green point up there? I haven't started pattern graphing, have I? How did I realize that green point existed? I found where across the y-axis. I found the vertex. How do I know that green point exists? Using the axis of symmetry, so I'm just reflecting over the axis of symmetry. My graphing pattern is not 1, 3, and 5. It's going to be what? Close. -2, -6, -10. Okay? So from here, I'm going to go right 1, down 2. Oh, I'm already there. Left 1, down 2. I'm already there. Cool. So then I can do right 1 and down 6. Right 1 down 6. And left 1 down 6. Do I know the roots? Let's see. What would be my magical factoring number I'd go to? 1 times -2, so I get -2. I want the factors of -2, one being positive, one being negative, to add up to 4. Yay or no? And -2, the factors of -2 being one being positive, one being negative, add up to 4. It's not going to work. It's not going to work. Okay, so it's not going to factor, so I don't know exactly where it's crossing. But I'm going to come close. So these do exist. They're probably irrational, and I don't know exactly where they're at. So did we answer all the questions? Axis of symmetry? Got it. X equals 1. Oh, do I have a minimum or a maximum value as far as my vertex? Maximum? The maximum goes along with, the minimum and maximum go along with the y component. What is the y component of my vertex? 3. I have a max at 3. Cool. Max, min, vertex, we got domain. Ooh, domain, we can do this. Domain's always going to be what? Negative, positive, infinity. It's always a gimme. Range is what? Awesome. Negative infinity to 3. And it's a square bracket on 3 because it includes it. Okay? Axis of symmetry, we got max, min, we got vertex, domain, range. Interval where it is increasing. Roots, we don't know. Y-axis crossing. We have the y-axis crossing. Where is this increasing? I'm going to show you here. This is where it is increasing. The red. Where's it going? Coming from? Where's it going to? Going to what? It's going from, round bracket, negative infinity all the way up to what's the x component of my vertex? Huh?
Yeah, 1.
There's where it's increasing. Wow. Feeling okay about this? As we flip the page over, get up and around for a minute. Wave to the camera if you want to walk in front of the camera.
Hey, no.
You can make faces at it if you want.
Guys, you are on TV.
No,
Dude, I'm on YouTube.
I literally
Yeah.
have tears in my eyes.
30 more seconds. You want to wave to the camera? Oh, yeah!
For the camera?
Sure.
I'm on TV. Oh, hello.
15 seconds. Five, 4, 3, 2, and 1. All right. 2 more problems to review. You still with me?
You just copy.
Ready?
Yes.
Here we go. Y equals 2, parentheses, x minus 3, x plus 1. Bless you. This one looks a little different. How do I approach this parabola?
U equals 0.
Equals 0. Set each of your these equal to 0. So where's the cross in the x-axis?
X equals
3 and
-1.
-1. Okay, so if they're already factored out, you take each of the binomials, set it equal to 0, and that tells you we're across the x-axis. Like when we had it on our homework, we had it twice. That means sometimes the vertex could touch the x-axis. All right, so now I have to probably find where is the middle of -1 and 3. Yeah, it could be 1. It looks like if I come in 1, I come, yeah, 1. And what would I do in order to find the rest of my vertex? Plug it in. So I have 1 minus 3, which is, so I have to remember I got a 2. 1 minus 3 is -2. 1 plus 1 is, so where did this 2 come from? Where did that 2 come from? Yeah, that's it right there. All right, so 2 times -4, or 2 times -2 is -4. -4 times 2 is -8. I have my vertex, 1, -8. My -8 is going to be down here a bit. We'll draw down there. Sorry, I ran out of room on mine. Can we pattern graph? Yeah, it's not going to grow at 1, 3, 5. It's going to grow at what? What is it? 2 and 6 I agree with. 2, 6, 10, right? All right, ready? Where did the 2, 6, 10 come from? Because this was a 2, we multiplied our pattern graphing by a factor of 2. So I'm going to go right 1 up 2, left 1 up 2. Where's across the y-axis? There you go. So it's across the y-axis at -6. I want a total of 4 points to plot. Do I have a total of 4 points plotted beyond the vertex?
Yes.
Yep. So I can go ahead and graph from there, see if this is going to work for me. I like it. I like it. I like it. Okay. Is my vertex a minimum or a maximum? Minimum. It's a minimum value. What's my minimum value up there?
-8.
There you go. Okay, remember the minimum, maximum go with the y component of the vertex. Okay, what else can we do? Domain and range? Domain? They're all going to be this. Negative, positive, infinity. Range? -8. Positive infinity. Oh. -8. Okay. I'm sorry. -8 to positive infinity. Too many. Where does it appear it's increasing?
1 to infinity.
Increasing from what?
-8 to infinity. Yeah, 1 to infinity.
1 to infinity. And it's rounded bracket because it doesn't include it because it's at the flat.
I was right.
Did we answer every question? Did we answer every question on there though? We have the vertex, we have the axis. Oh, axis of symmetry, forgot. Don't want to lose that point. What's the axis of symmetry?
The axis of symmetry is x equals 1.
X equals 1. Yep, there you go.
Is the increasing where it crosses the x?
It's where it's went from coming down to started going back up. So the increasing is the opposite side if it opens downward.
Then how'd you get 1? But yeah.
Okay, so the dot.
So you look at the x component.
See how the dot is like
Oh,
right
wow.
up here.
Yeah. All right, last problem. Can we do it? What do you think? Reese, you ready to rock and roll? Yep. Giddy up. What? Y is equal to. Oh, you'll like this one. This one's one similar asked on the homework. Edit, paste. Uh-oh. How many x plus 3s do I have? 2. So this is one of those different ones. So this is, remember, this is going to be the same as writing it to look like this. X plus 3, x plus 3. So let's find where it crosses the x-axis. Where does it cross?
3 negative. No,
Just negative 3. Does it cross again? No. What do you know about that negative 3 right there? What point is it? Axis of symmetry. It's also our vertex. Vertex is negative 3, 0. Axis of symmetry, we can do that.
Why is it the vertex when we need to solve the y?
Say that one more time.
Why do we need to solve the y?
Well, it's going to be the vertex. In this type of case, when it happens twice, this is going to be, and it's going to come down and just bounce off the vertex because it was a double root, happened twice. Okay? Axis of symmetry is x equals negative 3. Okay? Oh boy. I think pattern graphing might be my friend on this one. It's going to grow at a factor of what?
1.
1, 3, and 5? Might not all fit, but we'll see. All right, so from here I'm going to go right 1 up 1. I'm going to go left 1 up 1. Still with me?
Yeah.
You can fill those 2 points in on your table if you wanted to. From there I'm going to go right 1 up 3. And it's going to go left 1 up 3. Does anybody have any idea where this would cross the y-axis?
14.
Close. Not 6.
7?
What? 9. If I multiplied this whole thing out, I'd get x squared plus 6x plus 9. So it's crossing the y-axis way up here at 9. Okay? Or the y-axis. I think I got enough to graph it. Okay, almost done. Come on, let's do it. Domain.
Yeah.
Okay, domain. Guys, girls, if anyone misses the domain on this, we're going to make you take spaghetti that's not cooked and try and inhale it up your nose and get it to come out of your mouth.
I can do less.
It'd be kind of cool. All right. What's the... My teacher's mean. Hey, what do you got? Oh, yeah, baby. Good job. Last thing. Increasing here. Good deal. Stevie's got it. Increasing from -3 to positive infinity. We answer all the questions? Guys and girls, that right there is how you do it. Do you guys want me to give you the other review sheet? I'll give you the problems, I'll go with it, and I'll record it.
Yeah.
You want that?
This one's
Smart. All right. This last sheet that you have, these are going to be the 4 problems I'll go over. I'll record these. They'll be at the back end of today's video. And if you want, you can go through them. Y equals 4 minus x squared. Y equals x squared minus 9. Y equals x squared plus 4x plus 4. And y equals 2x squared plus 4x minus 3. I'll work all those out at the end of this video for today. But if you wanted to try those, and then the video will be there for you to double check it towards the end. It is not homework. It's just extra review if you'd like to do it.
Oh yeah, there's just tests.
Alright. So we learned this little math business, right? It's a vertex and everything, but you already know that.
No b value, so it's 0. So that whole thing would be 0. Plug 0 back in, you get 4 out. Pattern graph is growing at a rate of -1, -3, -5. The reason that's is that negative there. Happens across the x-axis here and here. So you're able to tell what the roots are. The roots in this case, because it crosses the x-axis and you know exactly where, are -2 and +2. You have plenty of points. Domain, you'll all get this right. Negative to positive infinity. It has a maximum value. Our maximum value is at 4, so remember the maximum goes with the, so 4. Our range is going to go from 4 to -infinity, and it is increasing on this side here. That's where it's increasing. So it's increasing from -infinity all the way up to 0. Remember, the increasing goes with the x component. And I think we have everything labeled there. Okay, next problem. If you try doing your vertex, you don't have a b value, so -b over 2a is going to be 0. So your vertex is going to be 0, comma, -9. 0, -9. It's kind of like down here on mine. Okay. Axis of symmetry, we should get. It's going to be x equals 0. We could plot it as a dotted line, but we don't have to. Just have it labeled. We should be able to pattern graph off of this. So I'm going to go right 1, up 1, left 1, up 1, right 1, up 3, left 1, up 3. Okay. And it will actually cross here and here. The reason I know that is this is the difference of 2 squares, so you can go x plus 3, x minus 3 if you factored it out. Set both of those equal to 0. So that gives you x equals -3 and x is equal to 3. So you have your roots, because you know where they cross the x-axis. You have enough information to graph it. You have your axis of symmetry. This is a minimum value, so our minimum value is going to be at -9. Remember, the minimum goes with the y component of the vertex. Our domain will go from negative to positive infinity. As always, our range will go from, looks like -9 to infinity. It is indeed increasing here. That's where it's increasing, so it will increase from the x component to infinity. That problem's done. Next problem, we can go negative b over 2a. So negative b over 2a. Actually, let's go back to these last ones. Where did this one cross the y-axis? It crossed the y-axis at 0, 9. So you could label that. The one before that, it would have crossed the y-axis at 0, 4. Is that right? Yep. And then this one would have crossed at, that's our old graph. All right, so negative b over 2a. So I'm going to get negative 4 over 2a, which is 2 times 1. That's going to give me negative 4 over negative 2, which is negative 2. Plug that back in. Negative 2 plugged in, I'm going to get 4 minus 8 plus 4. So that's going to happen at 0. So at negative 2, 0 is my vertex. That's where it will cross the x-axis. In fact, my roots on this one, my roots are negative 2. That's where it's going to happen. It just happens to kiss the vertex. It opens up, we get pattern graph, so I can go right 1, up 1, left 1, up 1. From there, right 1, up 3. From there, left 1, up 3. My axis of symmetry is going to be x is equal to negative 2. Domain goes from negative to positive infinity. Range will go from 0 to infinity because it opens up. This is a minimum value. Remember, the minimum will go with the thing, so we get minimum at minimum at 0, and it is increasing.
Good morning, Cherry Creek High School. This is Emma Hingston. If you would like to say the pledge, please do so now. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thanks, Creek. Have a great wish week.
Okay, last problem. Negative b over 2a, so I get negative 4 over 2a. So that's going to give me negative 4 over 4, which is negative 1. Plug negative 1 in. I plug negative 1 in there, that's going to give me 2. If I plug negative 1 in there, it's going to give me minus 4, minus 3. 2 minus 4 is negative 2. Negative 2 minus 3 is negative 5. There's my vertex. My axis of symmetry, we know, x equals negative 1. So negative 1, negative 5 is down here. It does appear that it's going to cross the y-axis at this point, so 0, negative 3. So 0, negative 3 is here. Look at that, I am 1 over and 3 up, so I'm going to go 1 over and 3 up here. Okay. So there we go. So if I pattern graph, let's see, I'm going to grow at not 1, 3, 5, but I'm going to grow at 2, 6, 10. So I'm going to go right 1, up 2, cool. Left 1, up 2, we're already there. From here, I'm going to go right 1 and up 6. So right 1 and up 6, 3, 4, 5, and 6. Left 1, up 6, 1, 2, 3, 4, 5, 6. It does appear that it does cross the x-axis twice. I don't know if we can figure that out. Remember, if I multiply this times this, I get negative 6. Negative 6 factors that would give us for x. Well, I have 1 and 6 and 2 and 3. One has to be positive, one has to be negative. It won't factor, so these are irrational crossings. So our roots happen to be irrational. Domain we can do. Negative to positive infinity. My range is going to go from here, so from negative 5 to infinity. Our vertex is a minimum value on this one. So look at this right here. So our minimum value is at negative 5. It's increasing from the vertex over, so on this side. So the increasing takes place from negative 1 to infinity. And that is all of your review. So good luck for tomorrow. And we're going to go right into the quiz tomorrow. Have a good night.